Let's discuss one more question that we have already done in the context of surface area. Now we are going to do for volume. This is the arrangement, this is the figure. Now let's read the question. From a solid circular cylinder with height 10 centimeter. Okay, so there is a circular cylinder with height what? 10 centimeter. Let's label the height. So here it is 10 centimeter. So 10 centimeter it is done, and radius of the base is 6 centimeter. Radius of the base, okay, let's say this one, it will work. Radius of the base is 6 centimeter. A right circular cone of the same height. Okay, so cone has the same height, no worries, and same base. Okay, it has the same base, right? The same circular base that cylinder has, the same base cone is having. Find the volume of the solid. Remember, we have done this for the surface area, but this we are going to do for the volume. So let's start finding the volume. Let's start with the cylinder first. So before we find individual one, let me just tell you, we can do this question in a way better manner than finding the each answer then subtracting. Okay, so first of all I'm starting with the formula. Okay, volume of the cylinder. Let's start. Volume of cylinder is equal to pi r square h, right? And the volume of cone. Now volume of cone, that is 1/3 of cylinder. I'm using this knowledge that volume of cone is the 1/3 of volume of cone is 1/3 of the volume of cylinder, right? So I'm using this knowledge. Basically, what are we going to do? See over here, we are going to get the volume of cylinder. Yes. We are going to get the volume of cone. Yes. Then we are going to subtract because this cone is being removed from the cylinder. Obviously, simple. So generally what do? We substitute the values, get the answer in terms of numbers, then we subtract. But why am I not preferring this over here? Because you can see that there is a one common term, pi r square h, because we know that volume of cone is 1/3 of the cylinder. So let's use that fact over here and reduce our calculations. So volume of solid. So what I will be writing, volume of cylinder, pi r square h minus 1/3 pi r square h. Now let's take the things which are common. Pi r square h, okay, it's common. Pi r square h, there's nothing left, so 1 minus 1/3, right? So if you take the LCM over here 1 and 3, 3 ones are 3, 3 minus 1, 2. So what will be the volume? Volume will be, here let's write one time, pi r square h into 3 minus 1/3. So pi r square h into 2/3. So this is the volume of this arrangement. Now if we substitute this value of height, which is 10 centimeter, and r, which is 6 centimeter, then we can get the answer. Now remember, why are we able to do this? Because one important fact we need to remember, that radius of the base and height of the cone and cylinder is equal. If it is not equal, we cannot use this kind of steps here. Remember, radius is equal and the height is also equal. That's why we are able to use this relation. Otherwise, we need to substitute the values, simplify, get the answer for each of them. Then we need to do the subtraction. Now let's substitute the value. Pi is 22/7. R square, R is what? 6 multiply by 6 into h is what? 10. Done. And sorry, 2/3. So 3 ones are, 3 twos are. That's it. I think that's it. We can do cancellation, nothing more than that. So let's okay, nothing can be done. So let's multiply 22 as it is into 2 into 2, 4, 6 4s are 24, and there is 10 here and 7 in denominator. So 22 into 24, let's multiply. 24, 22, 4 2s are 8, 2 2s are 4, then 4 2s are 8, 8 and 4 will give you 12, so 2 carry over 1, 2 2s are 4 plus 1, 5. Here 528 into 10 over 7. So final answer is 5280 and 7 centimeter square. Centimeter cube, sorry, centimeter cube, it is volume. So that's it. Here this arrangement was possible, remember, because radius of cylinder and the cone, height of the cylinder and the cone is equal. So I have subtracted the area first because I use this relation that volume of cone is 1/3 of the cylinder. I used that relation, then I subtracted the area in terms of formula only. Then substitute the values and get the volume of this solid arrangement.